In this video, we're going to be talking about powers of 10 and scientific notation. So powers of 10, you're going to see 10 to either a positive number or a negative number. So a positive or negative exponent. So when 10 is to a positive integer exponent, if n is a positive integer, find the value of 10 to the n by starting with a 1 and moving the decimal point n places to the right. So they start out with the 10 to the fourth, and basically you can take 10 times 10 times 10 times 10, or there's a shortcut way of doing it. So you start with a 1, and we move the decimal place over however many the exponent is. So we started right here, went over 1, 2, 3, 4. And there's my new decimal place, and then just fill in the zeros in those little hills there. So 10,000 would be my number. Now, if it's negative, it works the same way, but we just have to move to the left. So 10 to the negative 6, start on the right side of the 1. I got to go back 1, 2, 3, 4, 5, 6. So there we go. And you can see them in the little diagram here. Fill in your zeros. Always put a 0 right there on the left side of the decimal place too. So 0.000001 is my number. And you might remember from the last section, 1 over 10 to the 6 is another way I could write that. Or 1 over, let's see, it would be a million. So 1/1,000,000th for that one. All right, so let's take a look at some examples. So find the value of each power of 10. So remember, if it's positive, you're going to move to the right. If it's negative, you're going to move to the left, the decimal point after the 1. So letter A, we got a 1 and 10 to the negative 3, so start on the right side. We got to go back 3. 1, 2, 3. There's my new decimal point. Fill in those zeros. So 0.001 be my decimal value of 10 to the negative third. 10 squared, so start on the right side of the 1. Go over 2. That will be 100. Now 10 to the 0 power. You can think about this two different ways. You might remember from the last section that anything to a 0 power is just a 1, which is true. Oh, excuse me. Or, if you start on the right side of the 1, 0 means you don't really move it at all, so it's just a 1. So however you want to think about it, but anything to a 0 power is just a 1. Okay, going through a few more. 10 to the negative 2 power, starting on the right side of the 1. Got to go back 2, fill in those zeros. So 0.01 for that one. 10 to the 5th, on the right side of the 1. We go over 1, 2, 3, 4, 5. Fill in those zeros. So 100,000 will be 10 to the 5th. And 10 to the 10th, pretty big one. Right side of the 1 over 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we got to fill in 10 zeros. Now you might notice that with the positive exponents, you basically just have to add that many zeros. So notice how we have 10 zeros here, we have 5 zeros here. Negatives work a little different, but there's just 2 decimal places for the negative ones. So we got 10 zeros, so that is 1,000, million, 10 billion. So pretty big number. So writing each number as a power of 10. So it's kind of like working the other way around. So what I want you guys to do is, again, start on the right side of the 1. And since I went to the, so go from like, and it's kind of like working backwards. So on the right side of the 1, how far did he go over to get to that other decimal place? Well, he went over 1, 2, 3, 4, 5, 6, 7. Or there's 7 zeros. So 10 to the 7th power for that one. This one, on the right side of the 1, I went over 1, 2, 3. So 10, and since I went to the left, it's going to be 10 to the negative 3. And just 10, when I'll start on the right side of the 1, I went over 1, so 10 to the 1 power. So just writing numbers as a power of 10. going the opposite way. So a few more problems where we're writing a number as a power of 10. So if you look at 2a, start on the right side of the 1, how many decimal places did I go over? Or how many zeros are there? And as you can see, there are 8, so 10 to the 8 for that one. 2b, start on the right side of the 1, how far left did I go over? 1, 2, 3, 4, so 10 to the negative 4th. And 0.1, so on the right side of the 1, I went over 1, so 10 to the negative 1 for 2c. So here we are multiplying by powers of 10. We talked about powers of 10 tend to a positive number or tend to a negative number. Now we're going to take those powers of 10 and multiply it by another number. Now they're going to work quite the same way. So for letter A, we have 97.86 times 10 to the 6th power. Now, like if we were going to look at 10 to the 6th, we start with a 1. But since we have that 97.86 there, what you're going to do is you're going to start with this decimal point, wherever that decimal point is. And since it's 10 to the 6th, I need to move that to the 6th to the right. So instead of starting on the right side of the 1, we're just going to start in the decimal place at that number. So fill in your zeros. So I have 97,860,000. So there's that number. Letter B, 19.5 times 10 to the negative 4th. Start off with that 19.5. And starting with this decimal place, I'm going to go to the left 4. There's my new one. Fill in your zeros. So we have 0.00195 for letter B. Scientific notation. So we talked about powers of 10. Here's the kind of lead into scientific notation. So it is a method of writing numbers that are very large or very small. And we're going to do some examples of that. A number written in scientific notation has two parts that are multiplied. So kind of like what we were doing in the previous slide. So the first part is the number that is greater than or equal to 1 and less than 10. So notice how 3.5 and 9.98, they're greater than 1, but they're less than 10. I like to think that there's one digit to the left of the decimal point, and it is not a 0. So that's also a good way to think about it. And the second part is a power of 10. So 10 to some power. That power can be positive or negative. So remember, has to be greater than 1, less than 10, or just one digit that's not 0 to the left of the decimal, and a power of 10. So let's take a look at some examples, and we need to determine if it is in scientific notation. So here we go, 0.4 times 10 to the negative 6. So the two things, the number in front and the power of 10. So see if those are okay. So 0.4, you might say, well, that is less than 1, or there is a 0 in front of the decimal point. So this one is not in scientific notation because of that 0 there. If it was 4 times 10 to the negative 6, then we'd be okay. But since it is less than 1, it is not in scientific notation. Now 6.9 times 10 to the second power. 6.9 is greater than 1 and less than 10. And 10 to the second is a power of 10. So that one is in scientific notation. That one is okay. And the next one here, 123.4 times 10 to the 8th. Something's wrong with that number, right? That is way bigger than 10, so that is not in scientific notation. Okay, looking at the last one here, I have 3.4. The 3.4 is okay. There's only one digit to the left of the decimal point. That's not a 0, or it is bigger than 1, less than 10. Looking at 8 to the 4th, though, is that a power of 10? No, it is not. It's just a power of 8, so this one is not in scientific notation. So you're going to see some numbers where some problems where you have to list the numbers from least to greatest. Now going through these powers of 10s And the scientific notations, you might have noticed that, well, if the power of 10, or the exponent of 10, is very small, or if it's very negative, those are typically the smaller numbers, which is correct. And then as those exponents get bigger, the numbers will actually get bigger. So to order scientific notation numbers from least to greatest, what you're going to do is start off with the lowest exponent. And notice how the lowest exponent, or the most negative, I guess, in this case, is that 9.9 times 10 to the negative 4. So that is the smallest one. Because remember, when we have a bigger negative exponent, we needed to move that decimal place over more. So I'm going to cross these out because it's a little bit easier to deal with. And the next exponent, I have a negative 1. Okay, so I have 2 of them here, though. So when you have 2 of them where the exponents are the same, you're actually going to determine which one is smaller by looking at the front number here. So which one is smaller, 1 or 1.2? Well, the 1 is. So 1 times 10 to the negative 1 is smaller. And then the 1.2 times 10 to the negative 1 will come next. All right, which one is bigger? That one right there with the positive 4. So 8.2 times 10 to the 4th. And I have 2 of them that have a 10 to the 5th power. So you just have to look at that number in front. Well, 2.4 is the next biggest one. So 2.4 times 10 to the 5th. And the last one will be that 6.2 times 10 to the 5th. So look at the powers. And if you have 2 of them that are same power, look at that number in front. So one more like this. So out of these, how many do I have? 1, 2, 3, 4, 5, 6. Which one has the lowest exponent? And looking around, looks like the 2 times 10 to the negative 12 is the lowest one. And the next highest, we have 2 that have a negative 30 power. So look at the numbers in front. So 4 times 10 to the negative 3rd, and then 5.2 times 10 to the negative 3rd. Notice how 4 is smaller than 5.2. And the next highest up, well, I got 2 that are to the 14th power. So the numbers in front, 3 or 4.5. I'll have to go with that 3. Then I'll go with the 4.5. And then finally, at 4.5 times 10 to the 30th will be my biggest number out of the 6. So next what we're going to do is write numbers in scientific notation. So if you look at the first one here, we have 67,000. And what you can do for all these is pick the spot on the number where the decimal point should go. So remember, we want 1 digit to the left of the decimal, and it's not 0. So for this one, we're going to put that decimal right here. So it's going to be a 6.7, and actually those zeros will just drop off. So how far to the right would you have to go to get to the end of that number? Well, you have to go 1, 2, 3, 4. Okay. Now, how do we do this? So going from left to right, the digits that I'm going to include are 6.7. Now, I'm not going to include those zeros on the end. The zeros will just be a given. But then I'm going to multiply by 10 to some power. So how far to the right did I go? I went over 1, 2, 3, 4. So 10 to the 4th for that one. And so to the right here, the point 0.00005, if I wanted to write that in scientific notation, you might say, oh, I'd want it here, but then I'd have to put a 0.5 for my first part. So we need to make sure to get that decimal point to have a number to the left of the digit that is not a 0. So after the 5. So the first number that I'm going to write down is a 5. I don't need to write down those zeros on the left side. And then times, and then how far did I go over? So 1, 2, 3, 4, 5. So 5 times 10 to the negative 5. So remember, I went to the left. That means I need to have a negative exponent. So 12 million. Where do I want to put that decimal point? In between that 1 and the 2. So I have 1.2 times 10, and times 10 to the what power? 1, 2, 3, 4, 5, 6, 7. So 10 to the 7th. Fix that up a little bit. 1.2, there we go. And the last one here, where am I going to put my decimal point? So you're going to put the point right there, in between that 9 and the 5. So starting this one out, I got 9.56 times 10, and then I have to go to the left 1, 2, 3. So 10 to the negative third for that one. So a few application problems when you're dealing with scientific notation. Recall that scientific notation was good if we had numbers that are really big or really small. So looking at biology, the human body is made up of 1 times 10 to the 13th cells. So write this number in standard form. So standard form is just the big, long, actual number that it is, not the scientific notation. So looking at this one, so 1 times 10 to the 13th. Well, with that 1, the decimal point's on the right of it. So 10 to the 13th, I got to go over 13. So filling in those zeros. So 13 zeros. Now, I don't know about you, but this is kind of a hassle writing all these zeros. So that is why scientific notation is a good tool to use. And filling in those commas, what would this be? That'd be million, billion, billion. This would be, so that's 10 trillion. In the statistics application. So the beginning of the 21st century, the population of China was about, and that is 1,287,000,000. So write this number in scientific notation. So think about where you want that decimal. You want that decimal right here, in between the 1 and the 2. So 1.287 times 10, and 10 to the what power? I went over 369, so 10 to the 9th. So a few more. We have a light year is the distance that the light travels in 1 year and is equivalent to 9.461 times 10 to the 12th kilometers. Write that in standard form. So we'll start off with a 9.461. And I need to start with this decimal place, move it over 12, because I got a 10 to the 12th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And fill in those zeros. Okay. So that is 9,461,000,000,000 kilometers. Next one, in 2003, population of Virginia was about 7,390,000, right, in scientific notation. So where do I want that decimal point? Well, in between the 7 and the 3. So 7.39 times 10 to the what power? Well, that's 10 to the 6th. So scientific notation is a good tool to use where we have numbers with that are really big or numbers that are really small. It's just a big time saver.